Okay, fine. Are the voice and screen clear? All okay? Tell me. Hmm? Yes. Okay, fine. Let everyone join. Okay. Let everyone join. We'll wait for 2 minutes. Okay. Fine. So the statement that we wrote is this: the gases behave ideally at high temperatures and low pressures. Okay. Now why it is so? When the gases are called as ideal, see, very simple thing it is. Write down. The gases are ideal, or gases behave ideally. Gases behave ideally. Just write it down. We will get it. Gases behave ideally. Ideally, if the molecules of the gases, the molecules of the gases, if the molecules of the gases, gases behave ideally. If the molecules of the gases, the molecules of the gases do not interact, do not interact. In bracket force, interaction means force, right? Gases behave ideally. The molecules of the gases do not interact. Now, what is the meaning of interaction? There should not be any kind of force. Okay. So there, write down. That is, intermolecular forces should be absent. Just write down. That is, intermolecular forces should be absent. Okay. Intermolecular forces should be absent. Fine. Intermolecular forces should be absent. Now you may ask, sir, if intermolecular forces are absent, does that mean at very low pressure intermolecular forces are absent? Does that mean at very high temperature intermolecular forces are absent? The statement that we wrote is something like this: if intermolecular forces are absent, gases behave ideally. Now, for gases to behave ideally, we may not make the intermolecular forces zero, but we can make them negligible. We may not make exact intermolecular force to be zero, but we can make it negligible. Very simple thing. Let's say this is the first molecule, this is the second molecule. If you increase the temperature of the molecule, sorry, gas, temperature of molecule, there is nothing like concept called as temperature of molecule. That's the kind of temperature of a gas. Let us increase the temperature of a gas. Okay, temperature of a gas is indicator of kinetic energy of the molecules of the gas. So, if temperature increases, kinetic energy increases. If kinetic energy increases, velocity increases. If velocities are very, very high, even when these molecules come very close to each other, let's say one is going like this, another is going like this, they may collide here. All those possibilities are there. But let me tell you, when these molecules, even though are very close to each other, they do not give enough amount of time to interact with each other. The velocities are so high, at high temperature velocities are so high that they do not give time for interaction, or the interaction time is negligibly small. It is so small that you can neglect those interactions. Interaction time is so small that you can simply neglect those interactions. The gas becomes ideal. So at high temperature, gases behave ideally. Are you getting this? Now you may say, sir, explain how the interaction force is zero in case of low pressure. Two conditions I said. Number one condition for high temperature. can be very easily explained because interaction time is so less. The speeds are so high, velocities are so high, that the interaction time is very less. Okay, sphere of influences overlap for very short amount of time. Sphere of influences overlap for very small amount of time. Okay, so that interaction will be almost negligible because that interaction time is negligible. That can be very easily understood. Now you may say, sir, how can low pressure make the gas ideal? Very simple. When the pressure is low, it certainly means number of moles of the gas is low. Let us try to understand step by step. We know it is PV equal to nRT. Okay, PV equal to nRT will be satisfied at low pressure. We are saying why? Let's say some volume of the gas is there. If P is low at given temperature, let's say, let us fix the volume, let us fix the temperature. Let us fix the volume, let us fix the temperature. Okay, so if we are saying that pressure is low, certainly number of moles are going to be low. If number of moles are less, it means that number of molecules are also less. If number of molecules or number of particles are less in given volume, if number of particles are less, let me repeat again. If in given volume number of particles are less, it means that average distance between the molecules is more. It means that average distance between the molecules is more. So one molecule is here, another molecule is here. Will there be any interaction at low pressure? Possibilities of interactions are again very low. Speeds may be low. Sorry, the pressure is lower. Speed may be high or low, whatever it is. Just forget about the speed. Average separation between the atoms at low pressure or the molecules at low pressure is high. Okay, between the gas molecules. Let's say only 1000 gas molecules are there in this entire room. Then that gas will behave ideally. Okay, are you getting this? Okay, but in that case, other approximations, for example, or the other approximations of kinetic theory may not be directly applied. For example, kinetic theory says that gas is made up of large number of particles. Now, 1000 molecules is not large number of particles. Okay, but try to understand the thing that at low pressure, the molecular separation or the intermolecular separation between the adjacent molecules on an average is large. It is so large that interactions are again negligible. So, in this way, we can say that at low pressure and high temperature, gases behave ideally because there are no interactions, no interactive forces between the molecules. Interaction forces, molecules मध्ये जर कुठल्याही टाइपचा attractive and repulsive force नसेल, if there are no attractive and repulsive forces between the molecules, then the gas behaves ideally. This is the condition. This is the condition of gas to behave ideally. Okay. So there are some gases which behave ideally. Okay. Container. Yes. Yes, it ultimately depends on the container because gases will occupy entire available volume. Okay, so in that case, let's say you are given certain number of moles. 5 moles. 5 moles means how many molecules? 5 times Avogadro number, right? So these many molecules are given to you. Let's say initially a small container is given to you. In that case, in that small container, if you fit all these molecules, pressure will be high. At high pressure, they will not behave ideally. Okay. Now, let's say you are given this much volume. See, this volume is so much and this volume is how much. So in that case, average separation will increase, pressure of the gas will decrease. If the pressure of the gas decreases, average separation increases, or average separation increases, pressure of the gas decreases. Both are. Separation increase, pressure decrease. Pressure decrease, gas behavior goes towards ideal. It may not be exactly ideal, but it goes towards the ideal curve or towards the ideal behavior. Okay. Now, online people tell me, up to this point, is the discussion clear to all of you? The point we say that high temperature and low pressure gases behave ideally. Is this point clear? Yes or no? point discuss करूया like घेऊया पुढे. Good. Fine. So this point is also over. Fine. Now let us try to understand how to calculate number of moles. You may be knowing this, but let us write down the formula. Right now, calculating number of moles. I am simply verifying that you know all the concepts because now these concepts will be required for physics. So I will be covering these concepts. Calculating number of moles. Just give me a second. Calculating number of moles. Okay, number one formula. See, for number of moles, you have to use the symbol small n. You people use the symbol as mu. Okay, but we will be using this. Okay. Okay, we are going to use n. Any look of you all. Take it. इंडिया मध्ये काय आहे लोकशाही त्यामुळे असं कर so n is equal to mu is equal to number of moles. How to calculate number of moles? Very simple. Write down given number of molecules divided by Avogadro's number. Given number of molecules divided by Avogadro's number. So small n is equal to capital N upon Na. Always remember these symbols. We are going to preserve our notations. We are going to conserve our notations for given number of molecules. Number of molecules I will be using the symbol capital N. Avogadro's number Na. Number of moles N. Fine. Sir, this formula we already know. Yes, I know. थोडंसं मोठं लिहायचं आहे. ओके फाइन. खूप मोठं आहे ऑलरेडी. ठीक आहे, अजून थोडंसं मोठं लिहू. फाइन. जर वाचता येत असेल तर मोठं लिहायला सांगू शकता. नेटवर्क जर व्यवस्थित असेल तर वाचता येईल. नेटवर्क व्यवस्थित नसलं तरी चालेल, काही अडचण नाही. I'm recording. Please slow down. Fine. But still I will increase the concept just okay. N is equal to N upon N. Avogadro number of molecules and number of moles. ऐसे relation आम्हाला माहित आहे. Fine. N equal to काय? Just give me a second. N equal to U च्या खाली. N equal to U च्या खाली. ठीक है. This is the notation used by other people. You. And this is the notation which we are going to use. N equal to U नहीं है, N equal to mu है. Okay. Which number of moles? Get familiar with all the notations. Fine. Number one done. Number two formula for calculating number of moles is given mass of substance in gram divided by tell me divided by molar mass in gram. Molar mass in gram. Okay. Now what is molar mass? Eka moles का mass. What is molar mass? Mass of 1 mole of substance. Keep on writing. Mass of 1 mole of substance. Mass of 1 mole of substance is called as molar mass. It can also be found very easily just by writing or let me write is equal to only molecular mass expressed in gram, molecular mass expressed in gram, that will directly give you molar mass. Okay, it is mass of 6.022 into 10 raised to 23 molecules. Not a single molecule. It is mass of 1 mole. It is mass of 1 mole of substance. 1 mole of substance is what? 6.022 into 10 raised to 23 molecules. If these many molecules, if we weigh together, let's have completely weighed molecular mass. Here, in chemistry, weight and mass concepts are same. Okay? In chemistry, molecular weight, molecular mass, both the terms will be written in gram. Molecular weight, molecular mass, both the terms will be written in gram, not in Newton. Okay. So this is molar mass. Fine. So let us write the formula. Number of moles is equal to m, total mass given, total mass of the gas or the substance given, total mass divided by, of course this mass should be in gram. If this is in gram, this must be in gram. If this is in kilogram, this must be in kilogram. So how to write molar mass in kilograms? Very simple. Okay. Or before that, let us first write down the formula and then we will go for writing molar mass in gram, writing molar mass in kilogram. Okay. We will not have any kind of confusion. Okay. Very simple unit conversion is there. Just follow the rules which I have already taught you for unit conversion. Every time you will end up with the correct answer. Fine. Without any confusion in the unit. So total mass of the substance which is given to you divided by molar mass. Molar mass symbol capital M. Molar mass symbol we are going to use capital M. Okay. M total is total given mass. Capital M is molar mass. Okay. Now let us try to write molar masses of few substances. Nitrogen का molar mass कैसे है? Molar mass of N2 is equal to Am I asking mass of one molecule of nitrogen? No, I am not asking mass of one molecule of nitrogen. I am asking if I take Avogadro number of molecules of nitrogen, which is 6.022 into 10 raised to 23 molecules of nitrogen. Molecule of nitrogen is N2, not N, is N2. Such how many molecules I have to take? 6.022 into 10 raised to 23 molecules I have to take. Now if I weigh them together, what will be the number? That will be called as molar mass of nitrogen. That answer can be found out very easily. It is the molecular mass expressed in gram. Now what is the molecular mass? That is the atomic molecular mass number, not atomic mass number. Molecular mass number for nitrogen will be what? 7 is the atomic number of single nitrogen. Okay. 14 is the atomic mass number for single nitrogen. How many nitrogens are there in one molecule? 2. So 14 into 2, that will give you 28. So 28 gram is what? Is molecular weight number. Just like atomic weight number, 28 is the molecular weight number or molecular mass. Now that molecular mass we have to express in gram. So what I shall write here? 28 gram. Okay. Unit must be gram per mole. Most of the people forget this. Molecular mass unit they write only as gram. This unit काय पाहिजे बघ? Gram per mole. एक मोल म्हणजे 28 ग्राम. 1 mole means 28 gram. Okay. Everyone, online people, tell me, is this unique point clear to all of you? It is gram per mole and not only gram. Okay. Otherwise, this equation will not be satisfied. Gram cancel. Mole la mole नको. This mass will be given in gram. This mass must be in gram per mole. 10 gram cancel, and this mole in the denominator go to the numerator, mole equal to. Okay, काही fundamental mistakes होतात मुलांकडे. या सगळ्या आपण बघून काढतो. This will help you in chemistry also. Okay, all this formulae will help you in mole concepts also. Fine. So, how to write nitro for nitrogen, molecular mass of nitrogen. Okay, now you people tell me what is the molecular mass of ozone? Ozone is O3. Ozone is O3. Okay, oxygen is O2. And nascent oxygen is O. Nascent oxygen. Have you heard this word before? Single oxygen. Single oxygen atom. Very reactive. So it will form bond immediately and it will become both stable bond. Both again stable bond. Yes, correct answer. Patkan sanga mala. I know now the unit is gram per mole. No need to write the unit. Just tell me the correct answer. It is 48. Perfect. It is 48. All of you are giving the correct answer. So जरा मला verify करून घेऊ दे या सगळ्या concepts. So how to write it? Molecular mass of O2. Okay, it is 48. Sir, gram per mole. Fine. बरोबर आहे. Fine. No problem. Now, most of the silly mistakes done by the students. Okay, let me check how many of you do the silly mistake and how many avoid the silly mistake consciously. If you know the concept, if you know how the definitions are, if you know the definitions, if you know what are the units, then you will not make any kind of mistake or silly mistake. Tell me, for helium, deliberately I am writing the word helium. For helium, what is the mass? What is the molar mass? Helium. Molar mass. 4 or 2? Reply in the chat box also, online people. Helium. Molar mass. How many gram per mole? Helium. Multiplies. See, I got one answer as 2, one answer as 4. Again one answer as 2, again one answer as 4. Certainly means there is confusion. There is mistake. Okay, what are the rules? Try to follow the rules. Now deliberately, and I wrote the word helium. Okay, now helium, symbol is He. How many protons are there? 2 protons, 2 neutrons. Perfect. So 2 protons. Let us write it here. Number of protons, number of neutrons, number of electrons. Okay, this chart you must know for almost all the elements. At least first 30 elements you should know. Okay. For proton, sorry, number of protons in the helium 2. Neutrons 2. Electrons 2. Okay. Or 3. So, what is atomic mass number? Sorry, let us write atomic number. Atomic number is equal to Z. Definition of atomic number is what? What is definition of atomic number? Number of protons is the definition. Don't say number of electrons. We know atoms are neutral. We know atoms are neutral. Hence, for a neutral atom, number of protons is equal to number of electrons. And hence, this number of electrons, but basic definition is number of protons is called as atomic number. Okay. Now, atomic mass number. Atomic mass number. Let us verify all the basic concepts in today's lecture. Okay. It is denoted by the symbol. Representation capital A. It is number of protons plus neutrons. It is number of protons plus neutron. Don't double the number of protons. Don't double the number of neutrons, because in every atom equal number of protons and neutrons must be there. Condition. Okay, in the atoms or in the nucleus, number of protons and number of neutrons may not be equal. So basic definition is number of protons plus number of neutrons. This is the only correct definition. With this you will never make a mistake. Fine. Now let us write atomic mass number. Okay. Let us write symbol of element. Symbol of element. is always written like this. Let's say the letter for the element is X. Here, at this subscript, what you have to write? Atomic number or atomic mass number? Atomic number, Z as. You may write Z here, no problem. You may write Z here, absolutely no problem. We don't have any problem. Just write it here. You may write atomic number here, we don't have any problem. You may write atomic number here, again we don't have any problem. Here you have to write the total charge, here you have to write mass. Total charge of the given entity, and here total mass of the given entity. You have to write like in this fashion. The system वरती charge, त्या system चा charge number इथं लिहायचा, त्या system चा mass number इथं लिहायचा. Okay. Charge number will be right now given by the protons. Okay, here we are writing symbol of element or nucleus, right? Symbol of element or nucleus. Okay, symbol of element or nucleus. Fine. Now for helium, what is the value of A? That is atomic mass number. Helium atomic mass number. Helium molecule, tell me, helium molecule is monoatomic or diatomic? This is also one of the confusions. Helium is, write down along with me, monoatomic molecule. Okay, it is inert gas. You know helium, neon, argon, krypton, xenon, radon. These are the noble gases. They do not interact with each other. Okay. All of these are monoatomic. Okay, helium is monoatomic gas. See, it is gas. Okay, it cannot be very easily liquefied. So it is also called as permanent gas. Oxygen cannot be very easily liquefied. Okay, so it is also called as permanent gas. Fine. So helium is monoatomic gas. Its melting point is very low. It is very close to also. It is closer to absolute zero also. Its melting point. Okay. Its boiling point is also low. So at the room temperature, it is already boiling. So right now it is in gaseous phase. Okay. Helium is monoatomic gas. See, one simple logic, one simple trick you should remember is this. The gases which we observe at room temperature must have their boiling point and melting point less than room temperature. Oxygen, nitrogen, carbon dioxide, all of these are the gases in our atmosphere. These are the gases in the atmosphere. If they are the gases at room temperature, what does that mean? Their melting point, their boiling point, the melting and boiling points of these substances must be less than the room temperature. So in this way, you can eliminate 2 or 3 options. Okay. So data of melting point, boiling point may not be always given, but there should be some sense, some logic. Fine. Now we got it. Now helium is a monoatomic gas. Helium is a monoatomic gas. So molar mass of helium He, not He2, He is equal to what? Is equal to what? What is the atomic number for the helium? 2 proton plus 2 neutron. 2 proton plus 2 neutron is 4. So whatever the molecular mass is there, now the molecule is nothing but atom, because helium molecule is helium is monoatomic molecule. Helium molecule means helium atom. But oxygen molecules mean two oxygen atoms. Some molecules are monoatomic, some molecules are some molecules are triatomic. Helium is monoatomic. Even though it is monoatomic, number of protons plus neutrons is activity is counted. It is 4. How many atoms are there in the helium molecule? 1. So what is the atomic number for 1 helium? 2. Atomic mass number for 1 helium? 2 plus 2 is 4. So write down 4 gram per mole. Okay, this is the correct answer. Now similarly, again Many of these students again do silly mistakes here also. For hydrogen, tell me what is the molar mass of hydrogen without any mistake. I know the unit is gram per. Tell me. Online people, offline people, tell me. Well, without any mistake, I want perfect answers. I want. Now some answers are 2 and some answers are again 4. Check correct. कौन 4 answer देते हैं, कौन 2 answer देते हैं. Let me check. So now everyone has given the correct answer. Means now the concept is clear. Other than mistaken. Good. So hydrogen is monoatomic or diatomic? Hydrogen is diatomic. So we have to write it as molar mass of H or H2. H2 is equal to. Now for hydrogen, number of protons in one hydrogen, how many protons are there? 1. Neutrons absent. Electron 1. So in this way, tell me, what is the mass number of hydrogen? One hydrogen. एक hydrogen का mass number कितना? Proton plus neutron. For one hydrogen, 1 plus 0. Proton plus neutron is 1. Mass number is 1. If mass number is 1 for one hydrogen, such 2 hydrogens are there. So 2 into 1, that will become 2 gram per mole. 2 gram per mole. In this way, molar masses are to be written. We have written molar masses of monoatomic, diatomic, as well as triatomic molecules. Ozone one घेतले. So now there will not be any kind of mistake while writing the molar mass. पण इथं हेच काम आहे. basics clear होतील. So and even मुद्दाम घरी काय करायला. What are the things you know and the things which you don't know, or the things in which you make silly mistakes? We are just verifying that we will not do any kind of mistake. Fine. Now this is also clear to us. Okay. Now we will be able to calculate molar masses. We will be able to calculate number of moles. Number of moles is one formula. There are 2 formulas. The first formula is what? If total number of molecules are given to you, how will you find out the number of moles? Number of molecules given divided by Avogadro number. If mass of the substance is given, then in that case, what you will do? Given mass of the substance in gram. You have, if it is given in kilogram, you have to write in gram. Divided by molar mass in gram. How to write molar mass in gram? Just write molecular mass in gram. You will get molar mass in gram. But the final unit of the molar mass is what? Is gram per mole. Don't make silly mistakes. So many times I have seen many of the students writing it as 2 gram. No, it is 2 gram per. Okay, mass of hydrogen is 2 gram per mole. एक more hydrogen मिलाकर. Okay, they might say mass of hydrogen gas is. But 2 gram hydrogen is taken means what? 1 more hydrogen is taken. But if you are considering it as a molar mass, whenever the word molar mass is used, must write it as gram per. If you are using the word only as a mass, in that case you can use the unit as gram. Mass gram, molar mass gram per. Okay, mass gram, molar mass gram per mole. Fine, no problem. Now, fine. Now write down the next point as different speeds of gas molecules. Different types of speeds of the gas molecules are there. Okay. This point we will cover first. This point is given on the page number 114. So that should be covered first. Okay. So different speeds of gas molecules. Write down the heading. Number 1 in that first sub point. Average or mean speed. Average or mean speed. See, we are talking about speeds. Okay. Even though we may use the word velocity, but ultimately please note that it is speed we are talking about. Okay. No sense of direction is to be considered. Okay. Even though we may use the word sometimes velocity, but it is ultimately equal as speed. Okay. Number 1, average or mean speed. Just give me a second. Sir, is it under ideal gas or next heading? काही कर नेक्स्ट लिहायचं असेल नेक्स्ट त्यात लिहायचं असेल त्यात काही फरक पडत राईट डाऊन इट ॲज नेक्स्ट पॉइंट मला वाटतं काहीतरी सिरियस लावलं हा राईट डाऊन ॲव्हरेज स्पीड ऑर मीन स्पीड ओके डायरेक्ट फॉर्म्युला लिहायचं काही डेफिनेशन वगैरे लिहायची नाही व्हेरी सिंपल थिंग इट इज नाउ फॉर स्पीड okay for speed symbols which the people use are like this some people for speed they use c some people use v okay so we will be also using both these symbols okay sometimes c and sometimes v according to our need okay so let us write first of all average value okay so c average speed of gas molecules okay let's say there are total n number of molecules. C average is equal to question mark. Okay. Sometimes the average value people write it as like this also. C average, C bar. प्रति बार घंटे की परत खाली average मानायची गरज. Okay. B value of speed or average value of speed. Okay. Is equal to question mark. So let capital N is number of molecules. Number of molecules. Okay. Then let us write C1. Speed of first molecule. Speed of, just write all the conventions. Speed of first molecule. Keep on writing along with me. C2 is the speed of second molecule. And so on. Up to nth molecule. Total number of molecules are n. Speed of nth molecule. Fine. So how to find the average value of the speed? Equals to C bar or C average. Some people may use B average. Then they use no problem. C1 plus C2 plus C3 plus C4 up to Cn over divided by total number of molecules. Is this simple? Okay, it is this simple. Average speed of a gas. Okay. Average speed of a gas or average speed of gas molecules. There are n number of molecules. Each one is having different speed. Then what is the average speed of a gas molecule? This simple. Average speed of a gas molecule is addition of speeds of all the molecules divided by n. Point. First point is clear. Okay. Now write down second point. Second point. Most probable speed. Most probable speed of gas molecule or gas molecules, right? Of gas or gas molecules. No problem. Most probable speed of gas molecule.